Good morning or afternoon. I hope everyone is doing well when they start watching this video. This week we're going to be learning about some important measurements and different ways to measure things. And so it's actually a really important part of science that I'm excited to teach you guys. We did our Wonder Walk yesterday, or you should have done it for the day one material. And so we're going to start learning about everything that I had you guys start looking at yesterday. So the first thing, just again to keep you guys thinking about your scientific method and kind of just getting you guys ready for this lesson. My first question is, why is it important to measure things when using our scientific method? So we can see a quick reminder. We have a few steps in our scientific method. We have our observation, then our question, our hypothesis, our experiment, analysis, and conclusion. So we usually start just by observing something, and we want to answer the question of our observation. So we'll create an educated guess, experiment it, and then create an analysis and a conclusion. So what I think it's important to measure things is because when we experiment, we really want to have very concrete, very sure numbers. We want to have very clear numbers so that we can do an analysis with them. We also want, when we're designing our experiment, to design it in a way that someone else could do it and see if they get the same results. So we want to be very clear with exactly how much of something we are using. Why is it important to be able to describe things in science? I think I kind of just touched on that one already, is because we want to be able to make sure that as we do an experiment, someone can do the exact same one. So we don't want to just say we're going to use water. We want to say we're going to use 5 liters of water, so that the next person who wants to do our experiment knows exactly how much of something to use. And then what are different things we can measure? We can measure lots of things. A lot of the time we are measuring our time, how long it takes to do something. We can measure our height, how much we weigh. We can measure how much is inside something. Like when we say a water bottle is 750 milliliters, we are measuring what's inside. So there's lots of different things we can measure. So hopefully by the end of this lecture, we're able to describe what length, volume, mass, weight, and density are. So those are going to be our 5 important measuring units or measurements. And then we want to also understand the difference between mass and weight. That is something that still I and other people can get easily confused. So it's important to talk about that. So our first one, though, we're going to learn about is length. So what gets measured in length? I want you guys to think about this for just a second. So pause the video if you have to. But the things I thought of that we measure in length are our height, maybe our distance between towns, or even some ropes or cords get measured in length. So, and then again, please just pause the video for a second. What do we use to measure length? So what kind of things do we use to measure them? I thought of a ruler, a meter stick maybe, or a tape measure. And then again, or I shouldn't say again, but this is our definition of length. A reminder is anything that's underlined, I want you guys to remember or write down in your notes. So length is the straight line measurement between 2 points, and the SI unit is in meters. So SI stands for Standard Instrument Unit, I believe. Which just means that everyone has agreed that we're going to use this it's scientific unit. As for when we're doing science, the basic unit that we're going to use is meters. So, I also like this little cartoon. I think it does a good job that length is a type of measurement. It tells us how long or wide something is. We can also talk about the length of time, but that is a different kind of length. So when we're talking about length, we're thinking about how long something is. I found a good video to describe some volume stuff, and I have that linked in the same part of our classroom. So please pause this video and watch this short one about volume. But what we're going to learn, again, kind of just like length. Pause the video, what gets measured in volume, what can you think about? I thought of drinks, anything really liquid I think gets measured in volume, or maybe a box or different shapes we always measure. What do we use to measure volume? I was thinking either length times width times height, so we can see that that is how we have measured this rectangular prism I should say, or a 3D box, or water in a cylinder. So we learned yesterday that if we have a rock or an object that is not easily measured like this, we can place it in a cylinder and measure the difference in the starting volume of the water and the ending, and that difference is equal to the amount of volume of the shape. So the definition that I want you guys to remember is the volume is the amount of space an object takes up, and our SI units are meters cubed. So this meters cubed is an interesting unit. It comes from that our volume is equal to our length times width times height. And if we were to plug in that our length's SI unit was a meter, and also for width and height we would use meters. 1 meter times 1 meter times 1 meter comes out to be a meter cubed. So that's how we get to meter cubed. And also I wanted to show you guys this equation that we did in our Wonder Walk yesterday. It's really important to remember how to define the volume of just a rectangular prism. Just like our other video for volume, please watch this one. It's linked in order in our classroom. It does a really good job of explaining the difference between mass and weight. So I'm also going to try though. Why is mass important? We're going to start with mass. Mass is a constant property that never changes. So mass is important to know because it's how much matter is in an object. It's also the same on Earth, on Mars, on the moon. It has nothing to do with the different gravitational pull, the different effects that our Earth will put on us. But our mass is the amount of matter in an object, and its SI unit is in kilograms. Sorry, I should have underlined this last little part where it says mass, the amount of matter in an object, and our SI unit is in kilograms, or kg. So that is what our mass is. It's the amount of matter. Now our weight is a little different. What gets measured by weight? I thought of, we measure ourselves. Sometimes we measure food, or we could really measure anything we want to by weight. What do we use to measure this? I usually thought of a scale. We just usually place it on a scale and then see what the number tells us. And our definition is that our weight is the measure of the pull of an object due to gravity. So we actually have an SI unit, which is a Newton, which is made up of a kilogram meter per second squared. But the easy one is Newton. But this has to do with the fact that the way we find our weight is we take our mass in kilograms and multiply it by this pull of gravity, which happens to be 9.81 meters per second squared. So we can come up with these SI units by doing that, but each object has a specific weight on it because of gravity pulling on it. So that's why our weight would change if we changed the gravity. And how do we do that? We do that by going to a different planet. So in our Wonder Walk yesterday, we learned that if we were on the moon, we would weigh less than if we were on the Earth. And we also learned that if we were on the sun, we would weigh a lot more, because the size of the planet, the size of the object we're on, affects how much gravity is pulling on it. So that's always an interesting difference. Our weight, it has to do by gravity, and our mass is just how much is in something. I like to think of mass like our volume. Our volume is how much we take up. Our mass is how much is in there. And then our weight is how much that amount of mass multiplied by the gravity that we have. Just like the other few videos, we have a good density video to watch. Those are all really short. I try to keep them really short for you guys because you have this one as well. But why is density important? Density can help see if something is pure or not because density is constant for pure objects. So our density is the same for all objects. It doesn't matter how much we have. If we have a liter of water or 10 liters of water, it's going to have the same density, and we'll talk through why, but that means it's a constant property. It's always the same no matter how much there is. So how does it get measured? It's actually, density is not measured, it's actually calculated. So we have a definition. Density is how compact the object is, but it's measured by density is equal to mass over volume. So we will take the mass of an object, which we just talked about what mass is, and divide it by the volume, which we just talked about our volume. So our mass tells us how much matter is in the object, and we're dividing it by how much space it takes up. So if something has a really low density, so our density is very low, it means that our volume is a lot bigger than our mass. So that is one idea. If we are struggling to remember the equation, I like to use this triangle to remember it. So our density is equal to our mass, which is on top of our volume. So just one way to think about it. And then the SI unit is we're going to take the SI unit from our mass and the SI unit from our volume and put them together. So it is a kilogram per meter cubed. So we have a few examples of how to calculate density. So our problem tells us that we have a mass of 8 kilograms and a volume of 4 meters cubed. So what is our density? I always like to start every problem this way, and I want you guys to do this as well, is to write down the important information from the problem. So our mass, or M, is equal to 8 kilograms. So that's what we get from right here. And our volume, V, is equal to 4 meters cubed. So then I want you to write down the equation you're going to use. By the end of the semester, we'll have quite a few equations. So I want you to write down the one you want to use, and then do your work by plugging in M and V. So density is equal to 8 kilograms. We'll just plug this M equals 8 into this part of the equation, and V equals 4 into this part, and this should be 4 meters cubed. Sorry, that is incorrect. And so then our answer is, we're going to simplify it down to 2 kilogram per meters cubed is our density of this metal cube. Let's try another. So we have a rock with a mass of 10 kilograms, and we have it placed in a graduated cylinder full of water. The water rises 1 meter cubed once the rock is placed inside. What is the density of the rock? So we're given that our mass has 10 kilograms, and that the volume of this rock is 1 meter cubed, because when we put it in our graduated cylinder, our water moved 1 meter cubed. So our equation, we're going to use the same equation. D is equal to M over V. And then we're just going to plug it in just like we did before. 10 kilograms over 1, this again should be meter cubed like this. Sorry about those those things that are incorrect. And then we get 10 divided by 1, which is just 10 kilometers, or 10 kilograms per meter cubed. All right, let's try one more. Sorry, that work should have shown up last, but a wooden box has a mass of 2 kilograms with a length of 1 meter, a width of 1 meter, and a height of 1 meter. What is the density? So we're given the mass and then a bunch of measurements. So the equations we're going to use is our volume equation, length times width times height, and our density equation. So now that we have our work, we can say, look over here, our volume is 1 times 1 times 1, so 1 meter cubed, and our density then is going to be 2 kilograms over 1 meter cubed. So I hope that makes sense. That is just a few examples to show you guys to get you started. If you have any questions, as always, please let me know.